Some brands built machines, others built legends. For over a century, one name has stood at the crossroads of innovation and tradition, transforming American agriculture from horse-drawn plows to hydrogen-powered tractors. Today, we're tracing the complete story of New Holland, from a blacksmith shop in Pennsylvania to a global powerhouse that's still rewriting the rules of farming. This is a journey through perseverance, engineering genius, and the iron will to feed the world. Chapter 1. The Blacksmith's Dream, 1895 to 1947. In 1895, in a small Pennsylvania town that gave the company its name, a blacksmith named Abram Zimmerman opened a repair shop in a horse barn. The town of New Holland sat in Lancaster County, surrounded by some of the richest farmland in America and populated by hard-working Pennsylvania Dutch farmers who valued quality, reliability, and honest work. Zimmerman understood their world completely. He'd grown up in it. He knew that when equipment broke during harvest season, every hour of downtime meant lost crops and lost income. He fixed what farmers broke and built what they needed. His hands were calloused from working iron, his vision was clear, and his reputation spread fast through the tight-knit farming community. Zimmerman's shop started small, handling repairs that other operations wouldn't touch. Broken plows, worn-out harnesses, damaged wagon wheels. Nothing was too humble for his attention. But Zimmerman had bigger ambitions than running a repair business. He watched farmers struggle with equipment that barely worked when it was new and fell apart after a single season. He saw inefficiency everywhere, and he knew he could do better. By 1903, Zimmerman had turned that modest repair operation into the New Holland Machine Company, a legitimate manufacturing concern with its own product line. He wasn't just fixing equipment anymore. He was designing it, building it, and selling it. His first major product was a feed mill, a mechanical grinder that could process grain into livestock feed faster and more efficiently than anything available at the time. Today, that machine seems simple, almost primitive. But in 1903, it was revolutionary. Farmers who'd been grinding feed by hand for hours could now process an entire week's worth in an afternoon. Those who'd been hauling grain to distant mills and paying hefty fees could now mill their own feed on site. That feed mill became the foundation of something far greater. For the next 4 decades, New Holland grew steadily, quietly, and with unshakable purpose. The company developed a reputation that couldn't be bought or faked. Reliability. Farmers didn't just buy New Holland equipment because it was available or because the price was right. They bought it because it worked. Season after season, year after year, the machines held up under conditions that destroyed competitors' products. When a New Holland implement broke, and everything breaks eventually, the parts were available, the repair was straightforward, and the machine was back to work quickly. The company expanded its product line carefully, manufacturing a range of implements that made farming less backbreaking and more productive, while maintaining the quality standards Abram Zimmerman had established in that first horse barn. But the biggest breakthrough came in 1940, and it changed everything. That's when New Holland engineers developed something the agricultural industry had never seen before: the first self-tying pickup baler. To understand why this mattered, you need to understand what haying was like before this machine existed. After cutting hay and letting it dry in windrows, farmers had to gather it, compress it into manageable bundles, and tie each bale individually with twine or wire. This was brutal, exhausting work, performed in blazing summer heat, with hands raw from handling rough stalks and sharp wire. A good worker could tie maybe 60 bales an hour. An entire farm crew working dawn to dusk might bale a few tons. It was slow, painful, and labor-intensive. New Holland's self-tying baler automated the entire process. The machine picked up windrows, compressed the hay into uniform bales, tied them automatically with twine, and kicked them out onto the field, ready for loading. One farmer operating one machine could now do the work of 10 men with pitchforks and wire. It saved time, it saved backs, it saved money, and it fundamentally changed how hay was harvested across America. That baler put New Holland on the national map. Farmers across every agricultural state wanted one, needed one, and lined up to buy one. Dealers who'd never heard of the company suddenly wanted to carry the line. The company that had started in a horse barn was now shipping equipment from Pennsylvania to California, from Texas to Montana. But Abram Zimmerman understood business reality. The agricultural equipment industry was consolidating rapidly. Small independent manufacturers were being absorbed by larger companies with deeper pockets and broader distribution networks. Staying independent meant fighting an uphill battle against giants with resources New Holland couldn't match. In 1947, Zimmerman made the strategic decision to sell to the Sperry Rand Corporation, a diversified industrial conglomerate with the capital and infrastructure to take New Holland to the next level. The company became Sperry New Holland, gained access to national distribution channels, and maintained the reputation for quality that had made it valuable in the first place. The blacksmith's dream had evolved into something bigger, something built to last for generations. Chapter 2. The European Connection, Clays, and the Combine Revolution. While New Holland was growing in America, another story was unfolding across the Atlantic that would eventually become inseparable from the brand's identity. In 1906, a Belgian mechanic named Leon Clays founded a company in the small town of Zedelgem, located in the flat agricultural heartland of West Flanders. His specialty was threshing machines, equipment designed to separate grain from stalks after harvest, one of the most labor-intensive and time-critical operations in farming. Clays built his factory by hand, brick by brick, with the same attention to craftsmanship that he put into his machines. That factory still stands today, over a century later, and it's still producing some of the most advanced harvesting equipment in the world, a testament to the vision of its founder and the quality of its construction. Leon Clays didn't just build threshing machines. He studied them, understood their limitations, and reimagined them completely. Early threshing equipment was stationary, requiring farmers to bring sheaves of grain to the machine. The process was slow and required multiple pieces of equipment working in sequence. Clays envisioned something better, a machine that could move through the field, handling multiple operations simultaneously. By the early 1950s, his company had achieved something remarkable. Europe's first self-propelled combine harvester, introduced in 1952. This machine could cut standing grain, thresh it to separate kernels from stalks, clean the grain to remove chaff and debris, and collect clean grain into a tank, all in a single continuous operation while moving through the field under its own power. This was enormous. Before the combine harvester, harvesting grain was a multi-step nightmare that required separate equipment for each operation and crews of workers moving between machines. First, you'd cut the grain with a reaper or binder. Then, you'd gather the cut stalks and transport them to a stationary threshing machine. Then, you'd feed the stalks through the thresher, collect the threshed grain, winnow it to remove chaff, bag it, and transport it to storage. Each step required labor, time, and coordination. Weather could ruin the crop between any two steps. A combine harvester eliminated all of that by doing everything in one pass. It was the single most transformative piece of agricultural machinery since the steel plow. Clays combines earned a reputation across Europe for reliability and grain quality. By the 1960s, the company had become one of the largest combine manufacturers on the continent, competing successfully against far bigger corporations. But Leon Clays understood that staying independent would become increasingly difficult as the industry consolidated. He needed a partner with resources, distribution, and complementary product lines. Sperry New Holland saw the strategic potential immediately. In 1964, they acquired a majority stake in Clays, rebranding the company's products under the anglicized name Clayson for English-speaking markets, while maintaining the Clays name in Europe. This wasn't just a business deal or a financial transaction, it was a strategic masterstroke that changed both companies fundamentally. New Holland now had instant access to European engineering expertise, European markets that had been difficult to penetrate, and most importantly, decades of knowledge in combine harvester technology. The American company that had started with feed mills and balers was now a transatlantic agricultural equipment manufacturer with operations on 2 continents. The Zedelgem factory became New Holland's European harvesting headquarters, and it would eventually become the birthplace of the twin-rotor revolution that redefined combine technology worldwide. That same year, Sperry New Holland introduced another innovation in North America that's still used on farms today, the haybine mower conditioner. Before this machine, cutting hay and conditioning it to promote faster drying required 2 separate operations, 2 separate trips through the field, twice the fuel, and twice the time. The haybine combined both operations into a single machine, a single pass. It cut the standing hay and simultaneously crushed or crimped the stems to break the waxy outer layer that held moisture inside. This allowed air to penetrate the stems, dramatically accelerating the drying process. For dairy farmers, this was absolutely critical. Hay that dried faster maintained better nutritional quality, which meant healthier cows, higher milk production, and more profit. Hay that dried too slowly could develop mold, lose nutrients, or even spontaneously combust in the barn if baled with too much moisture still inside. The hay bean became one of the most successful hay tools ever manufactured, selling hundreds of thousands of units over the following decades. It cemented New Holland's reputation as the go-to brand for forage equipment, not just in North America, but eventually worldwide. Dairy farmers, beef cattle ranchers, and horse breeders trusted the name for equipment that could handle their most valuable crops. But the real revolution, the innovation that would define New Holland for the next half-century, was still ahead. In the research facilities of both the American headquarters and the Belgian factory, engineers were working on something that would redefine harvesting forever: the twin-rotor combine. Chapter 3. Twin rotors and the birth of modern harvesting. 1975. That's the year everything changed in the harvesting world. That's the year New Holland introduced the TR70, the world's first production twin-rotor combine harvester, launching a technology that would revolutionize grain harvesting and remain at the heart of the company's combine lineup for the next 50 years and counting. To understand why this mattered, why this represented such a fundamental breakthrough, you need to understand how combines worked before this machine rolled into the fields. Conventional combines of the era used a single large-diameter threshing drum, positioned horizontally across the width of the machine. Crop flowed from the header and feeder house onto this drum, which rotated at high speed against a stationary concave. The violent impact between the drum bars and the crop knocked kernels loose from the stalks. The mixture of grain, chaff, and straw then fell onto straw walkers, reciprocating racks that shook material backward, while grain fell through openings onto cleaning sieves below. The system worked, and it had been working in various forms since the 1800s, but it had fundamental limitations that became more apparent as farms grew larger and harvest windows became more critical. The threshing drum was aggressive, too aggressive, in crops like soybeans or certain wheat varieties with fragile seeds. The high-speed impact between drum bars and crop-cracked kernels, reducing quality and market value. The straw walkers couldn't keep up with increasing capacity demands, pushed too much crop through too fast, and the walkers would become overloaded, sending grain over the back of the machine and onto the ground. Grain losses of 3 to 5% were considered normal, acceptable even, but that meant 5 bushels lost for every 100 harvested. On a large farm, that was thousands of bushels and tens of thousands of dollars left rotting in the field every season. New Holland's engineers knew there had to be a better way, and they found inspiration in an unlikely source: centrifugal force. The answer was radical. Instead of one transverse drum, they used 2 longitudinal rotors running parallel to the direction of crop flow. Instead of relying primarily on straw walkers for separation, they harnessed the power of centrifugal force generated by the spinning rotors. The design was elegant in concept, but extraordinarily complex in execution. Here's how it worked. Crop entered the feeder house just like a conventional machine, but instead of feeding onto a single drum, the flow split into 2 streams using a divider cone. Each stream fed into its own rotor, counter-rotating cylinders that spun at over 500 revolutions per minute. The rotors were surrounded by curved concaves, perforated with openings just large enough for grain to pass through, but small enough to retain stalks and straw. As crop material spiraled around each rotor, the centrifugal force generated by the high rotational speed pushed grain outward toward the concave surface. Grain escaped through the concave openings and fell onto cleaning sieves. Meanwhile, the heavier straw material continued spiraling along the length of the rotor through the separation zone, where additional centrifugal force continued ejecting any remaining grain until only clean straw exited the rear of the machine. The advantages were immediate and dramatic. Threshing was gentler because grain was separated by centrifugal force, pressing it through concave openings rather than by violent impacts from drum bars. Cracked kernels dropped from percentages measured in double digits down to single digits or less. Separation was more thorough because the crop spent more time exposed to centrifugal force as it spiraled the full length of the rotor, not just the brief moment it spent on straw walkers. Grain losses dropped from 3 to 5% down to 1% or less in most conditions. Capacity increased because the system could handle higher crop volumes without the straw walkers becoming overloaded, and the design was more compact, making the entire combine shorter and more maneuverable. The TR70 debuted with a 145 horsepower Ford engine, though some models featured an optional 166 horsepower Caterpillar power plant and a grain tank capacity of 158 bushels. By modern standards, these numbers seem modest. Today's flagship combines push 775 horsepower and carry grain tanks exceeding 500 bushels. But in '75, the TR70 wasn't competing on raw size. It was competing on technology, efficiency, and grain quality. And on those metrics, it wasn't just competitive. It was revolutionary. Farmers who ran the TR70 noticed something immediately. The grain coming out of the machine was cleaner and less damaged than anything they'd harvested before. Cracked kernels were rare. Foreign material in the tank was minimal, and losses out the back of the machine dropped dramatically. In high-moisture corn that would have plugged and stalled conventional combines, the TR70 kept running. In tangled down soybeans that would have wrapped around straw walkers, it handled the crop without complaint. In dense, high-yielding wheat that would have overloaded separation systems, it maintained quality and throughput. By 1978, New Holland had upgraded the TR70 to the TR75 with more power and refined rotor designs. A larger model, the TR85, joined the lineup to serve bigger operations. Throughout the 1980s and 90s, the TR series evolved continuously, adding models ranging from the compact TR75 up to the high-capacity TR99. Over 2 decades of production, New Holland built over 25,000 twin-rotor combines. Competitors took notice. International Harvester introduced their axial flow rotary combine in 1977 using a single large rotor. Gleaner followed with the N6 in 1979, also featuring a single rotor. John Deere eventually joined with their STS series using twin rotors, but with a different configuration. The rotary revolution had begun across the industry, but New Holland had started it and held the technical lead. The twin rotor design became the DNA of New Holland's combine lineup. It evolved, improved, and expanded across 5 decades, but the core concept remained unchanged because the engineers who created it in the early 70s got the fundamentals right. Even today, 50 years after that first TR70 rolled off the line, every New Holland CR series combine uses twin rotor technology. The current flagship, the CR11, produces 775 horsepower from a massive Cursor 16 engine, holds 564 bushels of grain in its 20,000-liter tank, and features 24-inch diameter rotors that dwarf the original TR70's 17-inch units. But the principle remains the same. Split the crop flow, feed it into counter-rotating longitudinal rotors, harness centrifugal force to separate grain from stalks, and deliver cleaner grain with lower losses than any other threshing method. That's not nostalgia or tradition. That's proof that the 1975 engineers created something so fundamentally sound that it still can't be improved upon, only refined. Chapter 4. Ford enters the picture. The blue oval meets yellow paint. By the mid-1980s, the agricultural equipment industry was consolidating at an accelerating pace. Companies were merging, acquiring, selling divisions, and in some cases, simply disappearing. The farm crisis of the early 80s had devastated the market. Farmers were going bankrupt. Equipment dealers were closing. Manufacturers that had survived for generations were suddenly fighting for survival. In this turbulent environment, New Holland had the product lineup and the engineering talent, but it needed something more: scale, capital, distribution reach, and the financial stability to weather whatever storms lay ahead. In 1986, an unlikely savior appeared. The Ford Motor Company stepped in and purchased Sperry New Holland for over $600 million, creating Ford New Holland Incorporated. Ford wasn't new to agriculture. Far from it. The company had deep agricultural roots, stretching back to the earliest days of mechanized farming. In 1917, Henry Ford himself had introduced the Fordson Model F, the world's first mass-produced gasoline tractor. That machine revolutionized farming as dramatically as Ford's Model T automobile had revolutionized transportation. The Fordson sold by the hundreds of thousands, bringing affordable, mechanized power to ordinary farmers who couldn't afford the expensive steam engines or high-end tractors that had previously dominated the market. Ford tractors had been icons for decades, known worldwide for ruggedness, simplicity, reliability, and reasonable prices. But by the mid-80s, Ford's agricultural equipment division was struggling despite producing excellent tractors. They had great machines but lacked a complete equipment line. Ford could sell you a tractor, but if you needed a combine, a baler, a forage harvester, or hay equipment, you had to go elsewhere. New Holland faced the opposite problem. They had industry-leading combines, balers, forage equipment, and hay tools, but their tractor offerings were limited. The merger made perfect strategic sense. Ford provided the tractor line and manufacturing capacity. New Holland provided everything else. Together, they became a genuine, full-line agricultural equipment manufacturer capable of outfitting an entire farm from a single brand. Under Ford ownership, New Holland retained its distinctive yellow and red colors for harvesting equipment and hay tools, while tractors proudly wore Ford's signature blue. The branding strategy was deliberate and respectful of heritage. Farmers trusted Ford blue and New Holland yellow. These weren't just corporate colors. They represented decades of reputation, reliability, and memories of machines that had served families for generations. The company wasn't about to throw that heritage away for the sake of branding uniformity. During this period, New Holland significantly expanded its range beyond traditional agricultural equipment. The company's skid-steer loader division grew rapidly, serving contractors and landscapers alongside farmers. Compact tractors for hobby farms and small acreages became an increasingly important market segment. Utility equipment for municipalities found its way into the product catalog. The company that had started with feed mills and balers was now serving farmers, contractors, landscapers, municipalities, and anyone else who needed reliable outdoor power equipment. But the most important development of the Ford era was still ahead, brewing in the engineering departments, and it would produce one of the most celebrated tractor lines in New Holland history. Chapter 5. Genesis. Innovation Under Pressure. 1991. Ford decided to exit agriculture. The automotive giant wanted to focus on cars and trucks, and the farm equipment business no longer fit the strategy. But before selling, Ford's engineers had one last card to play, Project 396, later known as the Genesis tractor line. Genesis wasn't supposed to be possible. Ford gave the engineering team an impossible mandate: design a world-class tractor fast, cheap, and good. Every engineer knows you can't have all three. You pick two, but somehow, Ford New Holland pulled it off. Development began in '89. By September of 1993, tractors were rolling off Versatile's assembly line in Winnipeg, Canada. The entire project cost between $32 and $36 million, a fraction of what competitors spent on comparable programs. The Genesis line debuted with models ranging from the 8670 to the 9280, covering from 150 to 240 horsepower. These weren't just ordinary tractors. They featured super steer front-wheel drive axles that delivered a 65-degree turning radius, 30% tighter than competitors. The axle didn't just pivot, it articulated, allowing the outside wheel to move in front of the tractor's nose for unprecedented maneuverability. Inside the cab, Genesis introduced the Sidewinder console, a revolutionary armrest design that placed all primary controls where the operator's right hand naturally rested. Throttle, transmission, hydraulics, everything was intuitive, ergonomic, and efficient. Operators loved it. Reviewers praised it. Competitors studied it. And Fiat noticed. The Italian automotive and industrial giant had been watching New Holland for years, impressed by the engineering talent and product innovation. Genesis sealed the deal. In '91, Fiat purchased 80% of Ford New Holland. The Ford name stayed on tractors for a few more years, but the transition had begun. New Holland was about to become a truly global brand. Chapter 6. Fiat's Vision, Building a Global Giant. When Fiat acquired New Holland, they weren't just buying a company, they were merging four legendary brands: New Holland, Ford, Fiat Trattori, and Clays. Each brought unique strengths. Ford contributed its tractor legacy and North American presence. Fiat brought decades of European engineering and a network of dealers worldwide. Clays added harvesting expertise. New Holland tied it all together. In 1996, at a worldwide convention in Orlando, Florida, the integration was officially complete. The brand was now simply New Holland, with a unified blue and yellow color scheme, a modernized logo featuring the iconic Fiat Leaf, and a product lineup that stretched from compact tractors to 800 horsepower articulated machines. Under Fiat's ownership, New Holland invested heavily in research and development. In 1993, the Genesis line had already introduced Super Steer and Sidewinder. In 1995, New Holland launched Precision Land Management, an early GPS-based guidance system that helped farmers reduce overlap, save fuel, and apply inputs more accurately. 2002 brought another milestone, the CR Series twin-rotor combine. This wasn't just an update to the TR line, it was a complete redesign. The CR 960 and CR 980 featured larger rotors, 17 inches on the 960, 22 inches on the 980, and grain tanks exceeding 350 bushels. These machines were built for modern farming operations, where speed, capacity, and grain quality weren't optional. They were essential. The CR series evolved rapidly. Engineers added IntelliSense automation, dynamic flow control rotor vanes, and OptiSpread residue management. In 2014, the CR 1090 set a Guinness World Record by harvesting 797 tons of wheat in 8 hours, over 29,000 bushels. That wasn't just a record, it was a statement. New Holland builds the fastest, most efficient combines on the planet. Meanwhile, New Holland expanded globally. Joint ventures in China, Turkey, Russia, and India brought the brand to emerging markets. Manufacturing plants opened on every continent. By the 2000s, New Holland equipment was sold in over 170 countries, backed by over 2,800 dealers. The Blacksmith shop in Pennsylvania had become a worldwide empire. Chapter 7. The Hydrogen Dream, Clean Energy, and the Future Farm. 2009, Paris, France. The SIMA, Machinery Show. New Holland unveiled something the world had never seen, the NH2, the world's first hydrogen-powered tractor. This wasn't a concept rendering. It was a working prototype, based on the T6000 platform, capable of performing every task a diesel tractor could. But instead of burning fuel, the NH2 used hydrogen fuel cells to generate electricity. Compressed hydrogen from a high-pressure tank reacted with oxygen from the air, producing water, heat, and electrons. Those electrons powered 2 electric motors, one for traction, one for the PTO and auxiliary systems. The NH2 produced 106 horsepower, ran virtually silent, and emitted nothing but water vapor. No carbon dioxide, no nitrogen oxides, no soot, just clean, quiet power. For farmers working in confined spaces like greenhouses or barns, this was transformative. No exhaust fumes, no engine noise, no heat buildup. But the NH2 was more than a tractor. It was the centerpiece of New Holland's energy-independent farm concept. The vision was simple but radical. Farmers could produce their own energy using wind, solar, or biomass, convert it to hydrogen through electrolysis, store it on site, and use it to power their equipment. No fossil fuels, no dependency on external suppliers, complete energy autonomy. Critics pointed out the challenges. Hydrogen storage was expensive. Fuel cells cost hundreds of thousands of dollars. Runtime was limited to 2 hours. But New Holland kept refining. By 2013, a second-generation NH2 had double the power, improved storage, and extended runtime. Testing began at La Bellota Farm near Turin, Italy, New Holland's first energy-independent farm. In 2017, New Holland introduced a methane-powered concept tractor at the Farm Progress Show. This machine ran on biomethane produced from crop residue and waste, achieving the same power and torque as a diesel equivalent with 80% lower emissions and 50% less noise. The farm-to-fuel cycle was closing. The sustainable future was coming into focus. Today, New Holland remains committed to clean energy. Over 85% of its product range can run on pure biodiesel. Methane and hydrogen research continues. The company partners with universities, governments, and environmental organizations to push the boundaries of sustainable agriculture. Some call it ambitious. New Holland calls it necessary. Chapter 8. Modern Mastery. Today's New Holland. Walk onto a modern farm today, and chances are you'll see New Holland Blue and Yellow. The brand that started with feed mills now manufactures tractors from 25 to 670 horsepower, combines capable of harvesting over 700 tons in a day, balers that handle any crop condition, and precision technology that makes every pass count. The Genesis name lives on in the T8 series, the flagship tractor line featuring SmartTrax half-track systems, auto-command continuously variable transmissions, and the latest IntelliView 12-inch displays. These machines deliver up to 435 horsepower, handle implements weighing over 20 tons, and feature the longest wheelbase in the segment for superior stability and traction. The CR11 Combine, introduced in 2024, represents the pinnacle of twin-rotor technology. 775 horsepower, 20,000-liter grain tank, 24-inch rotors, twin-clean dual-sieve cleaning system. This machine can harvest 18 rows of corn in a single pass, achieving capacities that would have been unimaginable when the TR-70 debuted in '75. New Holland's forage equipment remains best in class. The FR Forage Cruiser self-propelled harvesters deliver up to 907 horsepower, processing over 500 tons of silage per hour. The Big Baler, large square balers, produce bales weighing up to 1,500 pounds, with throughputs exceeding 40 tons per hour. These aren't just machines. They're production systems designed to maximize efficiency and minimize waste. Manufacturing happens at 18 plants globally, supported by 6 joint ventures and over 2,800 dealers. New Holland's administrative headquarters are in Turin, Italy, with North American operations based in New Holland, Pennsylvania, the same town where Abram Zimmerman opened his blacksmith shop in 1895. The company is part of CNH Industrial, a global powerhouse that also owns Case Wine H, Steyr, and IVECO. But New Holland maintains its distinct identity, its commitment to innovation, and its connection to the farmers who've trusted the brand for over a century. Recent initiatives include autonomous tractor prototypes, advanced telematic systems that monitor machine performance in real time, and partnerships with beekeeping organizations to promote pollinator health. New Holland isn't just building equipment, it's building the future of farming. The legacy continues. From a blacksmith shop to a global giant, from feed mills to hydrogen tractors, from 17 rotors to the most advanced combines on Earth. New Holland's story isn't just about machines, it's about the people who built them, the farmers who trusted them, and the engineers who refused to settle for good enough. Over 130 years, New Holland has survived depressions, wars, consolidations, and technological upheavals. It's been owned by Sperry, Ford, Fiat, and CNH Industrial. It's built equipment in Pennsylvania, Belgium, Canada, Italy, China, and beyond. But through every change, one thing remained constant: a commitment to making farming more productive, more sustainable, and more profitable. Today's farmers face challenges Abram Zimmerman couldn't have imagined: climate change, water scarcity, soil degradation, rising costs, growing populations, but they're facing those challenges with equipment that would have seemed like science fiction 50 years ago. Tractors that steer themselves, combines that adjust settings automatically, balers that monitor crop moisture in real time, and maybe, someday soon, fleets of hydrogen-powered machines running on energy produced right on the farm. That's New Holland's legacy, not just building better equipment, but constantly reimagining what's possible. Which chapter of New Holland's story inspired you most? The twin-rotor revolution? The Genesis tractors? The hydrogen dream? Drop your thoughts in the comments. And if you love stories about the machines that feed the world, hit that subscribe button, because this is just the beginning.